This is the screencast for example 3, section 5.4. Almost forgot. We're going to do power reducing identities, which have which give us a way to take a trig function that has a square and convert it to a trig function that doesn't have a square, only has a single power. Those can be used in stuff like example 3. Rewrite the cosine to the fourth in terms of a trig function with no power greater than 1. Well, cosine to the fourth, I know, is cosine squared times cosine squared, and I have a power reducing identity that will help me convert that to a expression with a power no greater than 1. So I'm going to take cosine to the fourth, and I'm going to change that to cosine squared times cosine squared of x, which means that's two different expressions of 1 plus cosine of 2u over 2 times another 1 plus cosine of 2u over 2. Now when I multiply all this mess together, the common denominator, or excuse me, not a common denominator, the resulting denominator is 4. And the numerator, I would multiply all this out, so I get 1 plus 2 cosine of 2u plus, cosine squared of 2u. I've got another square that I can't have. I can only have a power of 1, or no greater than 1. So I need to use the power reducing formula again with 2u. So I have 1 plus 2 cosine of 2u, that expression's okay, plus, now I'm going to take a new expression, a new power reduction, 1 plus cosine of 2. Now u in this case, whatever cosine was squared of. So u is now 2u. And I know that's a little bit confusing, but I took the cosine squared of 2u, the cosine squared of 2u. So it's going to be 4u when I plug it into the numerator. Now, let's see, denominator is 4. I don't like having a denominator in my numerator, so I'm going to multiply both the numerator and denominator by 2. Now I've got 2 plus 4 cosine of 2u plus, and now this denominator goes away, which is nice, 1 plus cosine of 4u all over now 8. Well, 2 plus 1 is 3, so I have 3 plus 4 cosine of 2u plus cosine of 4u all over 8, and I believe your book likes to divide each of these by 8, so they do 3/8 plus 4/8, which is a half, cosine of 2u plus, and then this would be 1/8 cosine 4u. Now these power reducing identities are really cool because you can actually prove them on your own. Another example of using trig identities you already know to prove the new ones. So I challenge you to do that on your own. Find out why sine squared of u equals 1 minus cosine of 2u all over 2. Or why maybe tangent squared of u equals 1 minus cosine of 2u all over 1 plus cosine of 2u. The now try problem for example 3 is number 39 in the exercises. Very similar situation. I have a sine to the fourth on the left and something that looks very much like the end result of the last problem we did, example 3. Well, I'm going to start out the same way. Sine to the fourth of x is sine squared of x, sine squared of x. I have a power reducing formula that tells me the sine squared of x reduces to 1 minus cosine of 2x all over 2. Now I've got 2 of those. So I'm going to multiply the numerators and denominators again. I get 1 minus 2 cosine of 2x plus cosine squared, of 2x. Here we go again, all over 4. I've got another situation where I need to use my power reducing formula, but this cosine squared isn't just of something. It's of 2 2x. So u is going to be the expression 2x. So when I plug into my formula for the power reducing expression again, I get in the numerator 1 minus cosine of 2u, and in this case u is 2x, what I was taking the cosine squared of before. All over 4. I got to get rid of that denominator in the numerator again. So I have 2 minus 4 cosine of 2x plus, now these twos kind of cancel. So I have 1 minus cosine of 4x all over 8. And again, let's see. Oh no, we actually have to make it look like this. I was going to say that your book wants it the other way, but no, this is a proof. I have to make it look exactly like this. So I'm going to factor out the, no, I'm going to combine the numerator first. Oh, I can do that both. I'm going to factor out the 1/8, the 8 in the denominator, and then that leaves me with the expression 2 plus 1, which is 3, minus 4 cosine of 2x minus cosine of 4x, which is exactly what the problem wanted my expression to look like.